All right, now we're going to start Lesson 6. Lesson 6 is the start of calculus. So what we're going to do first is we're going to do limits. Now, the definition of a limit is that as x approaches a, or a number, then the limit of f of x approaches L, or a value. So this means that, so if I look at, and I'm going to just do it graphically, and then I'm going to show you, then I'm going to go back to the definition. Okay, so if I have x and y, and I have some function, and this is just some curve f, and if I look at a, some value of x, and I look at, and I'm assuming now that f is continuous, so f is some continuous function, just because it makes a little bit more sense to start at it. So if I'm looking at as x approaches a from the left, so this is as x going to a from the left side, then the limit of x, of f, goes towards L. Now, notice that what the limit is giving me back is a y value. All right, so this means that the limit as x approaches a from the left of f of x goes to some value L. Similarly, if I look at as x approaches a from the right side, so as x gets closer and closer in a from the right side, then the value of the function gets closer and closer to that same value of L. In other words, the limit as x approaches a from the right of f of x goes to that same y value, L. If both of those happen, and both of those values are the same L, then the limit exists. And that means that the limit as x approaches a of f of x equals L. And that's what a limit is. It means that as I get closer and closer and closer, then my function becomes this value, L. And this point right here is a f of a. Now, it is only continuous if all of these occur, all right? And if it doesn't happen, so if it fails to approach this single value, so if f fails to approach this, then the limit does not exist, all right? Now, I can do this graphically, so I can draw the graph, and I can check it graphically. Woo! I can do it graphically, moving along the points, or I can do this with properties, or I can do this with properties using algebra, or I can do this numerically. And we're going to show some examples using all of it. All right, so here's a property, and from here to here, so from here to here, I'm actually using the fact that the limit is an operator. All right? And I know that f of L, from here to here, I'm using substitution. Okay? Again, I'm using the fact that from here to here, I can pull the constant out because limit is an operator. And there's a lot going on in higher math than it actually is a total operator. And here to here, I'm using substitution. Okay? Again, I'm using the operator. And here to here, I'm using substitution. And again, operator. And substitution. And guess what? It's the same thing. And substitution. And we have forgotten how to spell from one example to the next. Now, I add this condition on because before I did not have that limit was equal to 0. But because I have now moved it to the denominator, I have to add this condition on because it's in the denominator. All right? So now let's get to some examples. The first example is going to be using, I'm going to estimate all of these things and estimate all of these numbers and show by approximation. So if I put in the limit so for the first one, I'm actually going to put in 1.9 minus 2 over 1.9 squared minus 8 times 1.9 plus 12. And when I do that, I get negative 0.1 over 0.41, and I get negative 0.2439. And so what you do is you put each of these numbers up here where x is. All right, that's all I did. And so when I do that, I get each of these answers. So I get, for the second one, I get 243977.24, negative 24,99375. Here I get an error because I get 0 over 0. Here I get negative 0.25006. Here I get negative 0.25006. And here I get negative 0.25641. So what all of this shows me is that the limit as x goes to 2 of x minus 2 over x squared minus 8x plus 12 equals, or is approximately negative 0.25. All right, now I want to talk about this for a second, and I'm going to talk a little bit about notation right now. So let's talk a little bit about notation. Notice that when I wrote this answer, I wrote the whole question right here. Does it make sense to say 2, 3 divided by, that doesn't make sense, 12, 3 divided by equals 4? To me, that looks like you possibly meant 123 divided by equals 4, which makes no sense. So what you have to remember is that you are taking the limit as x approaches a of a function. Of a function. This right here is a function. So without having this function, you are telling me that the answer is negative 0.25. So how do I know? So if you just wrote, say that you just tell me that the limit as x approaches 2 equals negative 0.25. So are you telling me that the limit as x approaches 2 of x minus 2 equals negative 0.25? Well, that makes no sense because as x approaches 2 of this, that's 0. You have to have the whole function right here in order for this to make sense. This has to be the whole function in order for this to make sense. It is an operator. You have to make your notation make sense. Most of math, all of math, is about notation. So your notation has to be correct. If your notation is not correct, if you don't understand the notation, then it's going to be hard to understand what you're doing. All right? So now let's look about the next question. All right? So the first thing you're going to want to do, so your first step is to test x equal to 0. So this is going to be the limit as x goes to 0 of x minus 24 over x minus 4. So the first thing you're going to do is put 0 minus 24 over 0 minus 4. So that's negative 24 over negative 4, so that answer is 6. All right? And that is you're done. That's what your answer is. You're done. Okay? So let's go to the next one. So again, your first step is to test x equal to negative 3. So the limit as x goes to negative 3 of x squared plus 6x plus 9 over x plus 3 equals negative 3 squared plus 6 times negative 3 plus 9 is 9 minus 18 plus 9 over minus 3 plus 3, so over 0. This is no solution because you can't have 0 in the bottom. So second, let's factor. So we have the limit as x goes to negative 3 of x squared plus 6x plus 9 over x plus 3. So that equals the limit as x goes to negative 3 of x plus 3 times x plus 3 over x plus over x plus 3. So one of these cancels, and I'm left with the limit as x goes to negative 3 of x plus 3. Well, this limit equals negative 3 plus 3. So the limit as x goes to negative 3 of x squared plus 6x plus 9 over x plus 3 equals 0. So that's it. Now, I want you to notice that from here to here, once I put the negative 3 in, I no longer put this limit sign. All right? Okay. First thing is test x equal to 6. So I have the limit as x goes to 6 of x squared minus 6 over x minus 6. So that is 6 squared minus 6 over 6 minus 6. So that's 36 minus 6 over 0. So this is no solution. I cannot factor, so number 2 is to factor. I cannot factor the numerator because 6 is not a perfect square. So therefore, excuse me, therefore, there is no solution. The answer is no solution. No solution or D and E. So I will write that as the limit as x goes to 6 of x squared minus 6 over x minus 6 equals D and E. All right? Now, again, the first thing I do is I test. So I have the limit as x goes to negative 3 of x plus 3 over x squared plus 6x plus 9 equals negative 3 plus 3 over 9 minus 18 plus 9. So that is 0 over 0, so that's no solution. So 2 I factor. So that gives me the limit as x goes to negative 3 of x plus 3 over x plus 3 times x plus 3. I factor. So that gives me the limit as x goes to negative 3 of 1 over x plus 3. This still gives me 1 over 0, which is still D and E. So the answer to this question is still D and E, because I still can't get rid of this second factor.